Hello and welcome to my class. My name is Mark Collins. I'm a physics and mathematics teacher. But today I'll be teaching you mathematics, preparing you for the UTME exams. Well, we're very close to the exam. I'm sure you're preparing very, very well. So let's first look at the syllabus content. A lot of students just go into an exam or go into exams without even thinking about the syllabus. The syllabus is divided into 5 sections. We have the number and numeration, algebra, geometry or trigonometry, calculus, and statistics. Now for number and numeration, we have the following topics: fractions, decimals, approximation and percentages, indices, logarithms, and surds, sets, and number bases. Now, because of the constraint of time, I am going to teach you logarithms under number and numeration. The next is algebra. Here we have polynomials, inequalities, matrices and determinants, progression, variation, and binary operations. I'm going to teach you 2 topics here. That's the first one over there, polynomials, and the last, binary operations. Then we have geometry and trigonometry. Under geometry and trigonometry, we have coordinate geometry, Euclidean geometry, loci, trigonometry, and mensuration. Here I'll teach you coordinate geometry and trigonometry. And then we have calculus, differentiation, integration, and application of differentiation. Statistics is the last. Here we have measures of dispersion, measures of location, permutation and combination, probability, and representation of data. I'm going to teach you permutation and combination here. Now, if you look closely from the beginning where we started, number and numeration, you find out that most of these topics, about say 85% of them, are your normal WAEC mathematics topics. So the only difference, we have a few differences that were brought from the further maths textbook or the further maths syllabus into the mathematics. Now in your mathematics, you have all this, everything here is what you have in your math. Polynomials, you do have that, except binary operation. That's why I'm going to teach you binary operations, because many students find it difficult. And you get to find out it's very simple, very easy. Geometry and trigonometry. Coordinate geometry has been introduced into the mathematics syllabus. So that is very familiar. It was introduced about, say, 3 years ago. And then we have trigonometry, you have all of this. Then here, calculus. Now, JAMB expects you to have just an elementary knowledge of calculus, so you don't have to be afraid, okay? And then we have statistics. Permutation and combination is not in your mathematics syllabus, but that's why I'm going to teach you permutation and combination. So altogether, I'm going to teach you 8 topics. The first is logarithm, polynomials. Next, binary operations, coordinate geometry, trigonometry, differentiation, integration, permutation, and combination. Now, for my class, if you do not have your writing materials, your jotters and your pens, you probably would need more than one. Don't let me scare you. And then your past questions booklet. You can pause the video, get all these things because you need them. I'm not going to be telling you stories. I want to teach you mathematics. You get to learn mathematics by practicing. So you don't just watch the video, you need to practice. So get all these materials so that the work will be easy and you can follow along. Okay, so the first is logarithm. Now I have my marker here. I'm going to teach you logarithms on my board. Here. Now, of course, you did logarithms. I decided to choose logarithm as my first topic because, you know, the rule, you start from simple to complex. Now, logarithms, you did logarithms in year 10 or SS1. The first thing you think about logarithms are your laws. Your laws. So I'm going to run through just 4 of the laws that are very important, and then we solve questions from JAMB's past question booklet. Now, the first law is this. If we have log to base A xy, this would yield log to base ax plus log to base a y, or we say log y, log x to base a plus log y to base a. This is the first law. Now the second law, if you have log x over y to base a, this would yield log x to base a minus log y to base a. That's the second law. We're going to see how to apply these laws in solving questions. The third is very simple. If we have log x raised to power y to base a, this would give us y log x to base a. Now what happened here? This power has moved to this side behind the logarithm. So we have log x raised to power y to base a, giving us y log x base a. Now the fourth one is not a law per se. The fourth one just tells us how we can convert logarithm to indices and vice versa. So this is what we mean. If x equals to log y to base a, then y equals a raised to power x. Now, the first equation up here is logarithm, while this one is indices. Here we have been able to convert logarithm to indices. So take note of this because we're going to solve questions, that involve all of this. So I have a few questions that I put on the board. You can take a pause. You can pause the video at any point and then go over the laws so you have a very good understanding. All right, so you can press pause. When you're done, press play to continue. So let me assume you have copied these laws into your books. So let's have some questions. I have a few questions. I'm going to quote the year and the question number. So at the end of this class, just go back looking for questions that look like all the questions I'm going to treat in class. So we go. The first question I'm putting up here was taken from 2020, and that's number 14. Number 14, year 2020. Now the question says, if log 3 base 27 plus 2x equals to -1. Find the value of x. Find the value of x. If log 3 to base 27 plus 2x equals -1. Now it's very easy. So what we're going to do here is simple. We move this 2x over to the other side. So we have the solution. Log 3 to base 27 plus 2x equals to -1. If we move this over here, we have log 3 to base 27 on the left-hand side equals to -1 minus 2x. Now, if you remember what I did, number 4, when I gave you the laws, I tried to convert logarithm to indices. Now, how did I do that, if you remember vividly? Now, this would give me 3 equals to 27 raised to the power of -1 minus 2x. Now, let me take you back to indices. From indices, we learn that 27 is 3 raised to the power 3. So, we're going to form an index in 3 here. Bearing in mind that 27 is 3 raised to the power 3. So, that leaves us with 3 equals to 3 raised to the power 3. Try to use a bracket. I teach my students to always use brackets so you don't muddle things up. And then we have -1 minus 2x. You can see this. So this is raised to power 1 because 3 raised to power 1 is 3. So if I go open the bracket, what we have here is going to multiply everything here. So that will leave us with 3 times -1 minus 2x. 3 raised to power 1 on the left hand side. So because of space, let's find a space up here so we can continue what we're doing. I hope you can see this. So we have 3 raised to the power 1 equals, when you remove the bracket, 3 will multiply everything here, leaving you with 3 raised to the power minus 3. 3 times 1 is 3, so we have minus 3 minus 6x. So since we have 3 and 3, we can cancel. We therefore have 1 equals minus 3 minus 6x. If you bring this to the other side, I advise students to always keep the unknown to the left-hand side. So this would come here to be 6x equals, this would go over here to be minus 3 minus 1. 6x minus 3 minus 1 is minus 4. If we divide both sides by 6, 2 is a factor for both. 2 here, 3. We have negative 2 over 3. Now, if you check this question, that is option B. I'm sorry, I didn't put the options on the board. Option B. So option B, which is negative 2 over 3. That's the answer. So remember, we have applied the 4th law that I gave you here, which is converting logarithm to indices. So that's what we're going to do. We're going to see how to apply all those laws I gave you. I only have 3 questions on the logarithms. So let's take the next one. You can press pause at any point, go over everything, and then press play to have a good understanding of what we are doing. So we'll go to the next question quickly because we have a whole lot to do today. Now the next one is taken from 2013, question 7. And it says, if log 4 to base 10 equals 0.6021. I'm sure you're done with this part. Log 4 to base 10 equals 0.6021. Now remember, you're not allowed to use calculator in JAMB. The only calculator you're allowed to use is the system calculator, so it doesn't have all those functions that your normal calculators have. So let's go. Now log to base 10, log 4 to base 10 is 0.6021. Now we are told to evaluate log 4 raised to power 1 over 3 to base 10. Now what law is this? Press pause and go back to the law. If you check the law, this is law 3. Now the law says log x raised to power y to base a is y log x to base a. So if we apply the law here, log 4 raised to power 1 over 3 base 10 is 1 over 3 log 4 base 10. But if you check, we've been given log 4 to base 10 as 0.6021. So if we apply that, we have 1 over 3 times 0.6021. So if you do the division, this is division. This divided by this. 1 over 3 times this is the same thing as 0.6021 divided by 3. So this would give you 0.2007. And that is option A. Option A. So, very easy. Go over it again. Have an understanding. So we move to the next question. The next question is 2014, number 6. 2014, number 6. I hope you have your past question booklets there. 2014, number 6. It says if log 7.5 equals 0.8751, evaluate 2 log 75 plus log 750. Now look at this. This is 7.5, and then we have the value of this log. What do you observe? If you look closely, you observe there is no base given. When you have a question like this, the base is 10. Please take note of that. So it means log 7.5 base 10 gives us this. We should find this. Now it's quite simple. Let's go. 7.5, or rather 75, is simply 7.5 times 10. Of course, you must have been taught in primary school that when you're multiplying a number by 10, a decimal, all you need to do is to move the decimal point to the right. If you were dividing this by 10, you move the decimal place to the left. But you're multiplying, so you move to the right. So we can rewrite this as 2 log 7.5 times 10. Can you see this? Good. Plus log 750 is 7.5 times 100. Because I'll move the decimal point 2 places because of the number of zeros I have here, 1 and 1. So I fill this space with a 0, that is 750. So 750 is simply 7.5 times 100, as you can see. Now, let's work. I'm going to remind you about the first law, law 1. I told you we're just applying all the laws that I taught you. So the first law states that log xy base a is simply log x to base a plus log y to base a. Can you see this? Yes. So we can apply that here. Now, we have this. Take note that 2 is behind the logarithm. So that leaves us with this. We're going to introduce a bracket. This would be log 7.5 plus log 10. There is something I didn't teach you here. I believe you learned that when you started doing logarithm in school. That log 10 to base 10 is 1. Take note of that. Log 10 to base 10 is 1. So we have this plus log 7.5 plus log 100. Log 7.5 plus log 100. So this is what we have. Remember that we're given this already, log 7.5. Log 10 is 1. What do you think about log 100? If log 10 is 1, log 100 would be what? Let me take you back to the law. Log 100. Remember that 100 is 10 raised to power 2. That is 10 times 10. You get 100. This is more like saying log 10 raised to power 2 base 10. Now, if you remember vividly the third law, this would be 2 log 10 base 10. And since log 10 base 10 is 1, it's more like 2 times 1. 2 times 1. So 2 times 1 is 2. So we can apply that here. When we do, we have 2. Now you open the bracket. Log 7.5 is given here. 0.8751 plus log 10 is 1 plus log 7.5, 0.851, 8751, sorry, I beg your pardon. And then log 100 is 2. So if you add this up, you have 2. 1 plus this is 1.8751. Plus, this would give you 2.8751. If you clear brackets, it would mean multiplying 2 by this. So 2 times 1 is 2, 2 times 5 is 10. You take 1 to the other side, 2 times 7 is 14 plus 1, which is 15. You take 1 to the other side, 2 times 8 is 16 plus 1, which is 17. You write 7. You take 1 to the other side, 2 times 1 is 2, plus the 1 is 3. So if you add this to this, 2.8751, if you do the mathematics, you can take it somewhere else. Do that. Now this would give you 3, and then 5, and then 2, that is 12, and then 16, and 6. 6.6253. 6.6253. Now that is option D. Option D. 6.6253. 6.6253. That is how simple logarithm is. So I decided to start with a simple one. Or maybe I should tell you that I started with the hardest one, right? Anyway, everything is simple in mathematics. So I'm done with logarithm. You can check the past questions for questions that have to do with the laws of logarithm. I show you all the questions on the logarithm in your math past question booklet. Are simple. Very, very simple and very, very easy. All right, so let's take a break at this point. We'll be back shortly.